Alright, time for the solutions for the Master Quiz 10 review. So on this front side, you're listing what the translations are that carry the shape from the start, from the pre-image to all the other images. On number 1, you're going to start here and end up here, because these ones have the first primes on them. And they even drew the line here for you, so that's a reflection. So that's a reflect over that line, which if you have a horizontal line, it's y equals the number, and that is 1, 2, 3, 4, 5. That's y equals 5. And once you have that, they had to go from here down to here, which is looking like just a translation. So that's translate down 1, 2, 3, 4, 5. So let's translate down 5. Moving on to the next one. It looks like we're starting here, and then this one's our next spot. We had to reflect over this line here, so this one's also starting with a reflection. So this is a reflect over, and this line here in the middle, since it's vertical, is an x equals line, and that x value there is -2, so reflecting over x equals -2. And then the next one, it's keeping the same orientation as it shifts to this next part, so it's just going to be a translation. So that's going to be translate. We had to go right 1, 2, 3, 4. Yeah, right 4 units. And we had to go down 1. So down 1 unit. That brings us to 3, starting out right here. And my next one is this triangle, which is the same as my start one, but reflected over this line, already drawn for you. For some reason, all these ones start out with a reflection. This time we have this horizontal line, and if it's horizontal, you're going to have y equals, and you write down the height of that line. Y equals how high? Man, I can't fix my own handwriting. Fix over, and it's down 1, 2, 3. So that's the line. Y equals -3. And then they just have this shape to the right 2 units, it looks like. So this one is also followed by a translate right 2 units. And that brings us to the next one. Excellent. This one actually does start with the same thing. It's a reflection, so we start here, and then we end up here, reflecting over this line right there. Everything's just on the other side. Across from that, so this one also starts with a reflection. So reflect over this one, since it's vertical, is going to be x equals. This value here is 1, 2, 3. X equals -3. And then the next part is going from here down to here, which the orientation is the same. We have A, B, C, A, B, C. And so that's just a translation. So this one's also translate. It's looking like I had to go left 2, down 1, 2, 3. So that is translate left 2 units, down 1, 2, 3, 3 units. Okay, and that brings us to the next part, which is a little bit more challenging, mostly because we start here and we end here, and we know that it's going to be 3 transformations. We have to figure it out. Right now, my orientation is not correct, and if I were to reflect over my axis here, I would have something like that, which is not too bad, but something that I want to point out is the orientation is not quite right. So we're going to have to, if I reflect it over, I have C, and then A. I think there's a little typo here, because there's no way C is going to be directly across from B, so these are going to have to flip real quick. But it gives us this, which isn't too bad. What we'll need to do now, though, is actually rotate this up here and see if we can get close. So that right there is a reflection over this line. So I'm going to write that down. That's reflect over. That is the x-axis, which is y equals 0, by the way. So we got reflect over the x-axis to start. And then 2, we're going to need to do a 90-degree rotation. 90-degree counterclockwise rotation. And then 3, well, let's actually do that. So if we have our points here, B is going to end up being right there. I think. Hold on. B is currently at 3, 0. To do counterclockwise, you change the order and change the sign on the first one. Actually, yes, it's going to put them right there. So there's my new B double prime location. That was my B prime. And A, take the coordinates 3, -2, change the order, change the sign. You can get 2, 3. Yeah, so there's my A, and there's my C, so C double prime, A double prime. Gives you this guy here. And now we just need to shift everything right. 1, 2, 3, 4. So translate right 4 units. That gives us that one. And then brings us to the next section. 6. It's looking like we're going to have to, well, we need to start here, end up here in 3 transformations. Something that I would do is probably just reflect over this y-axis and then rotate it down and then shift left to get me to the right spot. If you reflect over, A is going to be over here on the right side. So there's my A prime. You have C prime down there. And then B prime is going to be here. I'm going to reflect that over, so I'm going to put that down. Reflect over the y-axis. And then 2, I'm going to do a 90 degrees clockwise rotation and bring it down here to get it on the same level. Around the origin. And something to remember, if you have a vertical section of your triangle and you do a 90 degree, it's going to end up horizontal. Or if you have something that's horizontal and you do a 90 degree, it's going to end up vertical. So that kind of helps me realize what I should do here. I want this to be laid flat like it is down here. So that's why I'm doing a 90 degree rotation. Unfortunately, that's not going to put me right on this right here. My A is actually going to end up being in the same location as it was. There's my A double prime. C is going to be here. It's going to be my C double prime. And then B is going to be down here at 1. B is going to be right there. So there's my B double prime. Now I have this triangle right there. And I need to take it and shift it, looks like left 1, down 2. So that's going to be a translate. Translate left 1 unit, down 2 units. And if you were to draw that, you'd get this particular triangle. And something to notice, the B's don't quite match up. So if you're trying to prove that these two triangles are congruent, these ones would not. Because if you were to translate, it does not match up. Just so you know. And that brings us to the rest of these. On this next section, you need to draw figure out how many lines of symmetry the figure has and draw them. So on this first one, I got one there, and the diagonals are also symmetry on this one. So this guy here has 4. 8 has infinitely many lines of symmetry. all you have to do is go through the center. You can draw there, you can draw there, you can draw there. Yeah, circles have infinitely many, so I won't even bother trying to draw them all because there's infinitely many. And that brings us to 9. This is an equilateral triangle, so if you draw your lines through the opposite side, halfway from both sides, all those are going to be lines of symmetry. So that one's got 3. 10 here is like if I reflect over that line, or that line, the horizontal one, vertical one, and I can also get these diagonals reflect over. That gives me 1, 2, 3, 4. Yeah, this one's 4 lines of symmetry. And then that brings us to this next guy here, which some of these are stretched out. You're just going to have to assume that this one has equal lengths on all the sides. And if you draw those lines, that one's got a ground to hold too. That diagonal one is not a viable line of symmetry. If you were to construct that on a paper, try to fold it over, it's not going to work. And that brings us to 12. If again you assume this is a equilateral hexagon, it's a regular hexagon, then you're going to have 6 lines of symmetry. If you say it's stretched, because I noticed like these are a little bit longer than this one, then this one would only have 2 lines of symmetry. That brings us to the next part. So on 13 is really similar to 12. You're either going to take 360 and divide by the 6, which will give you 60 degrees, or you're going to take that 360 and divide by 2, which would give you 180 degrees, depending on whether or not you're saying it's regular or not. On 15, all rectangles have 2 lines of symmetry. So since it's 2 lines of symmetry, you take 360, divide by that, you get 180. 17, this is a regular pentagon, which if you draw all your lines of symmetry comes out to 5. So if you take 360, divide by the 5, comes out to be 72 degrees. 14 has just 1 line of symmetry. So if you take 360 and divide by the 1, it stays out to be 360. It's going to be the same on 16 and on 18. So these are all 360 degrees. And that's going to be it for your solutions.